Hello everyone. In this segment, we will discuss a very important topic, which is MATLAB scripts. So sometimes when you are writing a big code and you want to save your calculations for later use or possibly later modification, you will need to save them in some sort of a file. And MATLAB offers you this option using the so-called MATLAB M files or scripts. So let's write this here. So there is the so-called MATLAB scripts, and these are usually files with .m format. Um, so what we have here is MATLAB, the desktop version of MATLAB. And the way we call or we start a new script is by going to the new script icon here, click on it, and then all of a sudden you have a file where you can start writing text. Now, it's better to save these scripts and give them names. So if I hit save, so I will call this, for example, test script, and it automatically is saved with .m file. So let me save this here, and then test underscore script. So you might notice something here, that the naming of the script follows exactly the same rules of naming variables in MATLAB. So if you recall, for naming variables of MATLAB, we have to start with a letter. We always start with a letter. And also the name is case sensitive. So if we write here capital T, it's a different script in comparison to a small t script. The other thing is spaces are not allowed. Spaces not allowed, just like a variable name. If you want to leave a space, replace it with an underscore. So obviously underscore is allowed, just like variable names. Underscore is allowed. Let's actually write some simple calculation here. Let's say x equal 5, semicolon, and then maybe z equal x minus 4. And I will not put a semicolon because I want this to be actually printed onto the screen. I will save this, and now I want to run the scripts, basically to run the calculations in the script, which, by the way, you might notice it started to appear, its name started to appear here on the left, test underscore script, because I saved it in this folder on my desktop. Now, how can I run the script? There are two ways to do this. One of them is to hit the run button, and that's usually happens, you will see it in front of you when you are at the editor tab here on the top. So if you are at the editor tab and you hit the run button, opening the script and hit the run button, so you get your z equals 1. And by the way, notice also that the value of x and z started to appear in the memory of MATLAB. So running scripts automatically generates variables, and these are automatically stored in the memory of MATLAB. One other very nice possibility in MATLAB, and in fact in all programming languages, is that you can write comments on your calculations. For example, in MATLAB, the way you do this is you type the percentage sign. So you notice the green thing here, the percentage sign, and then you start typing whatever you want. For example, this is my first script. And then you can even do a comment here. So this is, for example, X value. Comments, when MATLAB sees these comments, it doesn't execute any calculations. It simply ignores them, but they are good for us as humans because they allow you to remember your logic when you write your code. And it also allows other people who might actually need to use your code, update it, upgrade it, to actually understand your logic. So for example, I can write here, or maybe I can write this before the line. Here we compute Z, something like that. Of course, this is a very, very simple script, so maybe comments are not needed. But when you develop a very complicated software, you really need to document your code very well, and writing comments is a very good way to do this. So let me save and run again. Again, if I run, I get Z equal 1. By the way, I ran this a couple of times now, because every time I run it, it calculates Z equal 1. Let me clear the memory. Let me do CLC to the screen. And by the way, you can include this in your script. You can clear your memory before you run your script, and you can clear the screen before you run your script. Again, let's save this. Usually this is recommended, but from some experience, the clear and CLC might be problematic a little bit in the online version of MATLAB, and especially with Mac computers. But generally, if you cannot, if for some reason you get an issue when you clear or CLC in your scripts, you might actually clear and CLC in the command window before you start your calculation. Now, we would like to take an exercise and apply what we learned on scripts on some problem coming from physics. So let's see this exercise. We'll start actually a new script for this calculation. You can actually start the script from here, from the plus sign. So let me do the plus. Again, you get a script called untitled4, but I can save it with another name. I recommend that you take a minute here to read the problem and maybe attempt to solve it, and then we will also solve it right now. Okay, so I will be solving this problem in this script, and this is on solar radiation. So I plan to give my script a name that's compatible with the nature of the problem. So I will save this as solar_radiation, or rad. And again, as you see here, solar_rad appears here to the left. So let's actually analyze the problem together. The problem says that the sun radiates 3.85 times 10 to the power 24 joule per second of energy. So this is the sun. And it radiates all this giant amount, which is 385 times 10 raised to power 4 joule per second. All of which is generated by nuclear reactions converting matter into energy. We will use MATLAB an Einstein equation, which is the famous equation E, the energy equals mass times the square of the speed of light, to calculate how much of the mass of the sun is converted into energy. So the source of this energy is actually mass. Mass that has been converted into energy through nuclear reactions. But we want this mass to be calculated in 1 day. So that the time, we want to calculate the amount of the sun mass that's converted into energy in 1 day. So you might notice that this is actually power, because it's in units of joule per second. So if you want to calculate the energy, so you might recall that power is energy over time. And if you want to calculate the energy, you just need to multiply the power by the time. And the time here is day. So the time is in units of day, but the power given to us is in units of joules per second. So obviously you need to convert this day into seconds in order to get a final result for the energy in units of joule. Because if you use SI units, then this equation, the left-hand side has to be in joules, the right-hand side has to be in kilograms for the mass, and the speed of light is meter per second, which is again the SI units. So that lays the basis of the problem. We need to calculate the energy first, right? And then once the energy is available, the speed of light is also available, and I can calculate the mass as the energy divided by the square of light, the square of the speed of light. So let's actually start coding. And we will do, we will follow good practice of writing comments. First of all, I want to calculate the conversion factor from days to seconds. So let me write a comment here, conversion from day to second. Okay, and in fact, I will give this variable a name, conversion factor. I will give it a name which is compatible with what it means physically. I will call it day underscore to underscore sec. By the way, you cannot use a dash here, so it has to be underscore as we discussed in variable names. And that's basically, so one day contains 24 hours times 60 minutes times 60 seconds. So this is the amount of seconds in one day. All right, so that's our conversion factor. So let's save. And it's actually good practice to keep saving while you are, developing your package, your software package or software code, because otherwise, you might face, some power outage or something, and then you lose the effort that you have been doing. All right, so that's the conversion factor. Now I can calculate E, which is the energy. So let's actually write this here, energy calculation. So capital E, the energy, is the power given to us in the problem. I can actually even define a variable and I can call it power. So power equal 385 times 10 raised to power 24. Remember the E notation that we can use to write numbers in the scientific notation. So times 10 raised to power 24. That means that the energy equal power times the conversion factor, which is day underscore 2 underscore second. And maybe because I don't need this result, I will just put a semicolon here and I will save. Okay. Then after computing the energy, I am actually ready to calculate the mass. To calculate the mass, I also need to let MATLAB know the amount of the speed of light, how much is the speed of light. So C, let me define T, equals 3 times 10 raised to power 8, again in units of meter per second. By the way, I can write a comment. So this is, for example, in meter per second. And finally, now I'm ready to calculate the mass. The mass is the energy divided by the square of the speed of light. And you don't need to do brackets here because the square of light actually has the exponentiation has the priority over the division. And that's it. We are ready actually to run this code. So let me save this. And actually, I showed you one way to run your scripts, and that's using the run button. But there is another useful way, is that you go to the command window and you type the name of the script. This is called solar underscore rad. If I type the name on the screen, on the command window, it will actually run the script. So let's see. So there is actually an error. So let's see what is this error. Unrecognized function or variable day underscore 2 underscore 2 seconds. So apparently I made a mistake here in calling this variable. And in fact, MATLAB is very informative. So it tells me that the error is in line number 8. And if I click line number 8, I see the pointer automatically goes in the script into line number 8. And obviously the mistake here is when I recalled the variable, I made a mistake and I wrote another underscore 2. Let's save again. Maybe you would like to CLC and clear here, just, to be on the safe side. And then we can run this again. Let me run it by recalling the name of the file. And you can use the up arrow in the keyboard for that. So if I hit the up arrow, it tells me the previous script I used, and the one I need is solar underscore rad. And I think there is still an issue. Oh, okay. So we forgot now to put the other underscore. So let's put save here. Again, let's CLC and maybe clear and run one more time. Let's hope it runs. And yes, it does. And this is the mass in units of kilogram. So it's 3 points, a giant amount of mass every day that's transformed into energy from the sun. Let's recap now what we did so far. So far we discussed that we need to use MATLAB scripts to save our work, to save our codes for later usage and possible upgrade. The name of the MATLAB script, so the way you call them is from a new here, so you choose a new script. Their naming start with a letter, it's case sensitive, spaces are not allowed, underscore is allowed, and it usually replaces the space. And in fact, let me add something to this. I would say that in addition, do not use a common name. For example, don't call your file max. So this is not good. Or don't call it, for example, area. Or don't call it, for example, error. Because these common names are likely built-in functions inside MATLAB, and it's not recommended at all to name your file with files inside MATLAB itself. Okay, and then after that we took an exercise where we calculated how much mass is converted into energy every day from the sun using Einstein formula, and we learned good practice by inserting comments everywhere in the code so that we can understand the logic of the calculation. Thank you so much and see you in the next video.